Hello everyone, this is Dr. A, and for today we're going to be working on solving oblique triangles using the law of cosines. We learned from our previous topic, which is the law of sines, that when we are solving for oblique triangles, we use the law of sines to find the missing angle or the missing side of our triangle that is not right triangle or don't have a right angle. And for today, we're going to be working on similar types of triangle, which is an oblique triangle, but this time we're going to be using the law of cosines. So in the law of cosines, that means that there are cases of our triangles that we need to satisfy to be able to use the set of formulas that we are seeing in our screen. So the two oblique triangles that are given today would be the side triangle, which means we are given the three sides and all angles are missing. And the other one is that we are given the side, angle, and side of a given oblique triangle. And we have two sets of formula for this, the standard form and the alternative form, which we're going to be using in a little while given the set of examples that we have for today. So let's start with an easy problem involving the law of cosine. And why is this easy? It's easy because the given oblique triangles and its parts are already given, and all we need to do is to figure out a way on how to find the missing parts, which is in this case angle A, angle B, and angle C. This oblique triangle is what we call as the side oblique triangle because we are given the three sides without any angles. And when we are solving this particular oblique triangle, we need to focus on the longest side of our oblique triangle. And in this case, we know that the longest side is side B because this is going to be our reference point to be able to use the law of cosine to solve our oblique triangle. So since side B is the longest side, that means we can first look for angle B to be able to complete the missing angles of our oblique triangle. So to be able to do that, given that we have the standard form and the alternative form of our law of cosine, we are going to be using the alternative form because one of the angles or the angle of this oblique triangle is what we are looking for. So cosine B equal to a squared plus c squared minus b squared all over to 2ac will be the first formula that we're going to be using so we can solve our missing parts. Now, tip, when you are using your calculator, make sure that you are using your grouping symbols correctly because most of the times it's a little bit frustrating when we are using all the values of our A, B, and C correctly, but our values in our calculator is not giving us the right answer. And most of the time, it's because we are missing the parentheses or the grouping symbol for our numerator and the denominator. So how are we going to use our calculator to solve for cosine B? We know that A is equal to 8, B is 19, and C is 14 feet. So by direct substitution, we'll be able to find cosine B, which is equal to negative 0.45089. Now notice that negative 0.45089 doesn't match our given angle because we know that B, by inspection, is an obtuse angle and negative 0.45 is not a correct value for an obtuse angle. And we also know that our angles should all be positive, which means we need another step to be able to find the value of angle B using our scientific calculator. So what we're going to do is we're going to be using our scientific calculator or graphing calculator or online application and push inverse cosine so we can find the value of angle B. So using your calculator to find the measurement of B, shift cosine or cosine inverse, and then the value of your negative 0.45089, which is our cosine B, which is in our solution from our formula. By pushing enter, you'll be able to get 116.8, which is the degree measure for our first angle on our oblique triangles. So now that we know our angle B, which is 116.8, we're going to be using the law of sine this time so we can find the value of angle A. Now, are we limited to using the law of sines to find angle A? No. If you want to use the alternative formula cosine A, you may do so, but in this particular case, we know that the law of sine is easier to use to solve problems similar to this one. So what we're going to do is replace all our values in our law of sines. So we know that side A is given, which is 8 feet. We also know that side B is given, which is 19 feet. We also solve for the measurement of angle B, which is 116.8. So we'll have cosine, that's supposed to be cosine, and that's sine B. So we'll have sine 116.8. So we have sine 116.8. Forgive me for my values because I forgot to put the sine function, and it's very important to put sine 116.8 because if you use the calculator and forgot to press sine 116.8, you're not going to be able to find the correct answer. So by using cross multiplication, we'll have sine A is equal to 8 all over 19 times sine 116.8 degrees, which is going to give us 22.08 degrees. And by using the law of sine, we're able to find the second angle in our oblique triangle. So all we need to do is to figure out a way on how to find angle C, which is the easiest angle to find because we know that the sum of the interior angles of any triangle is equal to 180 degrees. So all we need to do is to add 116.8 and 22.08 and subtract it from 180, and we'll get angle C, which is equal to 41.12 degrees. And that is how we use the law of cosine given an oblique triangle with the case SSS. And solving this oblique triangle is a little easier because we are given the diagram and the values of the sides of our oblique triangle. What makes it a little bit more exciting is when we are solving word problems involving the law of cosine. And the reason why it's a little bit exciting is because we need to be able to visualize our oblique triangles by the given word problems in our example right here. So two airplanes leave an airport at the same time on a different runways. One flies on a bearing of 66 degrees northwest at 325 miles per hour, and the other planes, it flies on a bearing of 26 degrees southwest this time at 300 miles per hour. Now the question is, how far apart are the two airplanes after 2 hours from leaving the airport? So again, it's easier if we have the oblique triangles, but if we're going to visualize our oblique triangles right here, we can use our imagination, and we know that this is the north and the south direction. And I don't know why my let's move this a little bit so it's straight. So let's do it again and see if we can draw the angle straighter. So this is our triangle, and we know that this is north and this is south. The first plane left the airport at 66 degrees northwest. So this is north and this is going west. So northwest is going up right here. And the other plane is going southwest. So this is south and this is west. So this is the other plane going. And it formed an angle of 66 degrees for the first plane and the other one at 26 degrees. So this is our visual representation of the two planes leaving the airport, and we know that after 2 hours, we'll be able to compute how far apart they are by using our oblique triangles. So my drawing is a little bit off right now, but we know that if we have a better visual like this, we'll be able to solve our oblique triangles a lot quicker. So now that we have established our oblique triangles, that the two planes are leaving from the airport, one is at northwest and the other one is leaving with the direction at southwest. And the angles formed by these two airplanes will help us find the measurement of angle B, which is the angle formed by the two planes in our word problem. Why is this important? Because we know that we'll be able to solve that particular angle by adding the two exterior angles of our oblique triangles and subtract it from 180 to complete our 180 degrees. So from doing so, we'll be able to solve for angle B, which is equal to 88 degrees. And now that we have 88 degrees as our reference angle for angle B, we'll be able to solve for the opposite side, the opposite side of angle B, which is side B, by using the law of cosine. So this is a better visual of our oblique triangles. And notice that the distance from point B to point C and from point B to point A is 650 miles, and the other one is at 600 miles. And the reason is because we know that the velocity of the first plane is at 325 miles per hour. So after 2 hours, all you need to do is to multiply it by 2. So we'll have 650 miles. And for the other distance, we'll have 300 miles multiplied by 2, and after 2 hours, the plane is at 600 miles from its starting point. And we know that by using these values, we'll be able to use our law of cosines, since this follows an SAS case of oblique triangle. So that means we'll be able to solve for the distance between the first plane and the second plane after 2 hours. So by using our set of formulas, since now we are missing a side, instead of using the alternative form, we're going to be using the standard form. And the standard form right here that we're going to be using would be b squared equal to a squared plus c squared minus 2ac times cosine b. And by substitution and using our graphing calculator, make sure that you are using it correctly and make sure that you are in the correct mode, which is radian mode, to be able to solve for the correct answer. So by plugging in the values of A, C, and cosine B, which is 88 degrees, we'll be able to solve side B using our calculator. And again, make sure that when you're using your calculator, you are plugging in the correct values and using the correct grouping symbols to avoid frustration of not getting the correct answers. And by using your calculator correctly, b squared is equal to 755,278. And we know that we're looking for b and not b squared, so we're going to take the square root of both sides so that side b would equal to 869, which means the two planes after 2 hours is 869 miles away from each other. And this is how we use the law of cosine and, of course, our handy-dandy graphing calculator to solve for the missing parts of an oblique triangles given the SSS case and the SAS case. So now, using your knowledge and new skill in using the law of cosine in solving for the oblique triangle, see if you can find how far apart these two planes are after 2 hours, which is similar to the last example that I have provided you in our word problem. So this is how we use our formula for the law of sines, and of course the graphing calculator or scientific calculator or any application that you can use using your cell phone to be able to solve for the missing parts of an oblique triangle. This is Dr. E, and see you again next time. Bye!